Hey guys, this is Mr. Sal. This is just a quick review on absolute value equations and absolute value inequalities. Absolute values are the distance away from zero a value is, and when we're looking at equations and inequalities, we usually get two of them to solve. So thanks for watching. Please comment, like, and subscribe. An absolute value is just asking us how far away a value is from zero. Now, since this is how far away it is, all those values are always going to be positive. For example, if you lived south of here, maybe 10 miles south of here, right? You wouldn't say that you live negative 10 miles north of here. That'd be weird, right? You would describe it as being a positive value in a certain direction, and that is what an absolute value will do, is it makes it positive no matter what, okay? So it's not an opposite thing. As you can see there, the absolute value of -5, and yeah, this is the symbol for absolute value, and then we put in something inside of it, okay? So when finding the absolute value of x, we're just asking what values of x will make the statement true. So if I had the absolute value of x equals, I don't know, 10, then we're asking what value of x will make this true. Well, then x could be 10. But what other value is 10 away from 0? Negative 10 also. Okay? We end up with two values right there. So when we get this equation stuff, really what we're going to end up doing is splitting it into two separate equations. Because if I can get the inside of that absolute value to be positive, then we're good. But if I can get it to be the opposite, then we're still good, right? So if a is positive, that's okay. If a is 0, then x is just 0, whatever. You really can't have an opposite 0. So what value of x would make the absolute value 0 away from 0? Well, you'd just have to solve it if it were some kind of expression. If a is negative, then it has no solution, because it's weird.
So the absolute value can equal.
If we have the absolute value of something is the absolute value of something else, then their distances from 0 have to be the same, which means that, again, it doesn't matter if it's positive or negative. As long as they have the same distance away from 0, then we're good. So it produces two equations, x equals y, but x equals the negative y. That's part of splitting it up into two equations, which we'll see here in a moment. All right. So what about the absolute value of x equals negative a? No solution. We can never get a negative value out of an absolute value. Solve if there's more than one solution. We'll separate it with a comma. And since it is an absolute value, we should expect to see more than one solution. We should. Now, if this was just a regular set of parentheses, you would distribute the 6. Unfortunately, you wouldn't even distribute 6. You would distribute -6. And I'm telling you this because this is something I see very often on exams, right? You say, well, I'm going to distribute the -6 into the absolute values, which is something you should not do. You should not distribute that -6 because it's an absolute value, and we need to see how the -6 is going to affect the rest of the numbers outside of the absolute value first. Now, could you distribute that -6? You could, I suppose. But you'll need a little bit more experience than you have now to do that, okay? So do not distribute the -6. That's a non-example. Don't do it, even though your instincts will tell you to do it, okay? So what we want to do is manipulate this equation for the absolute value, meaning in the end I want the absolute value to equal some value, okay? Now notice there's no number in front of this. Well, there's a phantom 1 if you want it. And we're really adding 0 to this. So I can't have the 7 or the -6 right there. So to start this off, what I'm going to do is subtract 7 from both sides. And then at this point, I'll divide both sides by -6, which does give me the absolute value. And that's great. That's what we want. Okay. Now this allows us to get to that point where if I can just look at 9x minus 8, negative 9x minus 8. If I can get that to equal 9, then we're good, right? But remember, if I can get that negative 9x minus 8 to equal -9, we're still good. Okay, now I show it with the 2 separating out of the absolute value like this, okay? Now again, this is important for us to realize. I'm not taking the absolute value of 9x, negative 9x minus 8 yet. I would solve that for x, and then, once I know the value of x, I would put it back into the absolute value and solve it, and then take that absolute value. Here's what I mean by that is, in the end, what I will need is the absolute value of 9, which equals 9. That would be true. And then this one over here would be the absolute value of negative 9, which is still 9. That still is true. Okay, so when I look at these values, I'm looking at this 9 and this negative 9 in these 2 equations. All right, well, let's solve these. Looks like I'll have to add 8 to both sides on both equations. All right, then just one more step. We'll divide both sides by negative 9 on both equations. So that's a positive 1/9 right there, right? So I had a negative 1 divided by the negative 9, gave me a positive 1/9. Well, let's go back and check, right? Because this is the point, checking that we should see this absolute value of 9 and the absolute value of negative 9, which again came from these 2 values here. So let's go back and check. Well, dang it. I guess we want the whole thing, right? So I'm going to look at the whole thing. 7 minus 6, absolute value of negative 9. We'll do the x's 1/9, which should get us the negative 9 out of that. So minus 8, absolute value. Does this equal negative 47? Okay, well, by the order of operations, we would do the absolute values first. So negative 9 times 1/9 is negative 1 minus 8. The absolute value is negative 9. Remember, that's what we wanted, right? And that's what we got, and that's good. Of course, we had the rest of that stuff. So the absolute value of negative 9 is 9. So I have 6 times 9, which is 54, which we've seen right here, right? And that's minus 54 even. 7 minus 54 is negative 47. So at least this one checks off. X is 1/9. Same idea on this one, right? We're going to solve for the absolute value. So the absolute value equals some stuff, and then we'll split it up into 2 equations. All right, so I'm going to start by subtracting 6 from both sides. And then I'll divide both sides by 6. All right, now at this point, like if you guys were working on this on a test or an exam, right, we get so used to just splitting it up at this point. I'm going to split it up. Then I got 3x minus 4 equals negative 7. Then I got 3x minus 4 equals 7. And that's a noble effort, okay? But really, we don't need to go any further than this point. Now again, this has to do with what an absolute value is, right? How far away a value is from 0. So what value is negative 7 away from 0? None, right? It just doesn't make sense, doesn't exist. So that's just the answer for this one. It does not exist. So, again, the question is, what value is negative 7, has a distance of negative 7 from 0? But since we're talking about distance, we never talk about distances in the negatives, which is why this one is it does not exist. Now, again, on a different level, we would say, well, an absolute value is always a positive. Well, this one now is spitting out a negative, which is no good. We can't have that, which again would produce a does not exist. Once again, we'll solve it. If there's more than one solution, we'll separate them with commas, whatever. We'll just box them in. So in the beginning, we saw this, and we can be glad that there's no real need for manipulation on this, okay? We just need the 2 absolute values to be the same distance away from 0, whether it's positive or negative. What this means is that when I split these up, and I always split up the one on the left, just a matter of habit, and it stays consistent that way. You could split up the one on the right if you wanted to, So that gives me 8x minus 7. But this would equal the other absolute value, which is 7x minus 9. But also the opposite of 7x minus 9. Okay. So this will produce, again, the absolute value, so the same distance away from 0, whether it's positive or negative. Now we tend to complicate this one a little bit more in our heads, right? Like, well, what if one's positive, the other one's negative, then the other one can be negative and the other one positive. It's the same thing. You're just moving where you're taking the opposites. That's it. But it's the same thing. Okay. Well, this gives us two pretty easy to solve equations on this. I guess this one over here, we got that -1, which we should distribute. Some of you would just change the signs, right? -7x plus 9. And that would work. So continuing to work with that one, I guess I would add 7x to both sides. Which also means I could add 7 to both sides. And then divide by 15 on both sides. And that gives me the x. 16/15. I'm okay with the fraction right there. Improper, that's okay. If you wanted the mixed number or the decimal, that's fine. Just be careful with the rounding stuff. Alright, on this next one, same idea. I'm going to keep the x's on the left, so I'm going to subtract 7x from both sides. And that means I'll add 7 on both sides as well. So I get -2. For example, this top one, I'm looking at the number lines, the top number line. That's what the answer looks like if it's the absolute value of x equals some value, okay? If the absolute value of x is less than a, then it becomes an intersection kind of thing. You don't even have to memorize these, and I'll show you why here in a moment, okay? If it's the absolute value of x is greater than a, then it becomes one of those or statements where they go off in opposite directions. Right? But I think there's a better way to do it. Okay? If we can just remember that if we ever multiply an inequality by -1, then it flips the inequality. Okay? That'll kind of help solve the problems for us, hopefully. Because we saw with the equations, right? We take one positive, one negative. Now when we're taking negatives for these inequalities, we're flipping the inequality for that one inequality. But we are still taking 2 though. Solve the inequality, and we'll give the answer in integral notation because we like it. So, all right, nothing to manipulate on this one, which is extremely convenient. So I can split this one right away into 8x plus 5 is less than 6. So that's just straight positive stuff. Didn't change anything, right? But on the other hand, right, if this was an equation, we'd take 8x plus 5, and we'd be comparing it to -6. But now that I've changed that to a negative, I'm going to flip the inequality right there. All right, well, from here, actually on both inequalities, we're going to subtract 5 from both sides. And now we'll divide both sides by 8 on both equations. So I got x is less than 1/8. And x is greater than -11/8. Okay, so when I go to graph this, then we should be able to figure out if it's an and or an or statement. So I got -11/8 somewhere over here. 1/8 will be to the right of it because they're on opposite sides of 0. That doesn't have to be proportional. And at -11/8, I would have an open circle. It's eating the x, so it goes to the right. And at 1/8, I would still have an open circle, but it's not eating the x, so it goes to the left. So it looks to me like we're specifically looking for the space between these two. Okay, which again should help us with our interval, starting at -11/8, and this goes to 1/8. And neither are included, so I'm using parentheses. Like at the top here, right, we got 8x minus 5 is less than 6. That's something that's happening inside that absolute value. So if I can get that inside to be less than 6, then it's going to give us a true statement. And then over here, if I can get x plus 5 to be greater than negative 6, it still gives us a true statement in the original statement. All right, let's go and solve this one with the interval. So once again, I'm going to split these up. Both of them, right, have the 9x minus 9. And one of these will be greater than or equal to 4, but the other one, in comparison with the negative 4, is going to flip that inequality. Well, we'll add 9 to both sides of both equations, and then divide by 9 on both sides of both equations. All right, well, we should be ready to graph these. Shouldn't need too much space on this. And I've got 5/9, which is to the left of 13/9. And for 13/9, I've got a closed circle because it's equal to, and it's eating the x, so it goes to the right. And at 5/9, still a closed circle. It's not eating the x though, so it goes to the left. So my interval notation goes from negative infinity, stopping at 5/9, which is included, so I got a square bracket. And we'll unite this at 13/9, which is included, so square bracket, and this goes all the way to infinity. And this would be my interval. All right, so graph this one. It tells us to use the u, like when you guys put this into the homework, which means right away we should know that we're looking at some kind of or statement, whatever. All right, so we do need to manipulate this one for the absolute value, just like we would an equation, right? So I'm going to need to subtract 4 from both sides. Then I'll divide both sides by 5. And I've got the absolute value of x is less than or equal to 1. All right, well, this one's going to split up just like the other ones, even though it's just an absolute value of x. Okay? So I need the absolute value of x. If I can get that x to be less than or equal to 1, then it would be a true statement. But if I can get the absolute value, just the x, to be greater than or equal to -1, it would still be good. All right? So when we graph this, I got -1 and 1 right here. Oh, that was tricky of them. So I'd have a closed circle at both locations. At -1, it's eating the x, so it goes to the right. And at 1, it's not eating the x, so it goes to the left. So they said to use the u stuff. That's weird, but yeah, this one we have starting at -1, and then this goes to 1, which also is included. So there's our interval. Yeah, no need for the u thing on this, right? Otherwise it would be an infinite solution thing. It would go from negative infinity all the way to positive infinity. Okay. If this was an or statement, it would be infinite solutions. We're going to get at that if it was the absolute value of x is greater than or equal to a negative. Because an absolute value is always positive, which means it doesn't matter what you put in for x, it would give you an infinite number of solutions. I like these ones. I like these ones a lot, actually, because we look at them, it's got lots of fractions. Makes us feel good. If we solve this, though, which we should do, and it will tell us why once we start solving it, okay? Why it's so nice is, well, let's subtract 5 from both sides. Now, just by instinct, we may want to combine the two x's inside the absolute value, but we shouldn't until we know that we manipulated for that absolute value first. See, I'm going to divide both sides by -3 now. Since I did divide by a negative on both sides, so I need to flip that inequality, right? And I got 9 divided by -3, which is -3. Now right here, we look at this. I have an absolute value that's greater than a negative, right? Is there any absolute value that's not greater than a negative? No, right? Because all those absolute values, no matter what you put in for x, it's always going to spit out some kind of positive value. So we got some kind of positive value, which is always greater than negative 3. So this one's all real numbers. It spans from negative infinity going to infinity. I suppose on the test I would just say all real numbers. But
That is because it,
those are the values that I can put in for x. What value could I put in for x? I could put in negative 100 trillion, and it would still give me a true statement for my original inequality because of the way it's solved, right? I could also put in some really large number, like 100 billion, and it would still be a true statement. Or you could try something really, really small, like 100th, and it would still be true. That's what it means. It goes, we can get an infinitely small negative, or we can get an infinitely large positive. Doesn't matter. All those values will make this statement true. All right, so having done that problem, we generally look at this next problem, this one, and we see, oh, it's less than a negative. Therefore, this one does not exist. But remember, yeah, there's other operations that are being performed on that absolute value, which we have to get rid of before we make that decision, okay? So on this one, we'll have to subtract 3. No, it is add 3 to both sides. See, and this is where it's going to change for us. Now that we need to divide both sides by negative 9. It is going to flip the inequality, but it's also going to make that a positive 7 right there. Like if this were a test and we saw that you said this does not exist because it's less than the negative 66, there's no points we can give you for that, right? So be careful and make sure you avoid that. Now that we have the absolute value in comparison with the positive value, we can split this up. And from here, we'll add 5 to both sides of both inequalities. And from here, it's pretty easy to solve these. We'll divide both of these inequalities by 2. And I got x is greater than 6, and x is less than negative 1. So just real quick on a number line, right? We got negative 1, 0, 6 is over here. So comparing 6, I got an open circle, it's eating the x, so it goes to the right. Negative 1, open circle, it's not eating the x, so it goes to the left. So our interval goes from negative infinity to negative 1, not included. And we'll unite this with 6, which is not included, going to infinity. That's it. There's our interval. Because really our steps should all be pretty much the same. So on this one, I'm going to add 8 to both sides of this inequality. And now I'll divide both sides by negative 3. And since I did divide both sides by negative, it is going to flip the inequality, right? So I got the absolute value of 6x plus 4 is less than 5. And now I'll split these up. And now we'll subtract 4 to both sides of both inequalities. It looks like we'll have some more fractions on these, but hopefully that's okay. We'll divide both sides of both inequalities by 6. So I got that negative 9/6, which I should reduce, right? I'll divide both of these by 3, which gives me negative 3/2. And now it's time to graph. So at 1/6, this is an open circle, not eating the x, so it goes to the left. And at negative 3/2, this is also an open circle. It is eating the x, so it goes to the right. So we can see it just intersects between these two, which gives us the interval, not included, the negative 3/2, going to the 1/6, which is also not included. And that's our answer. All right, why don't you guys take a moment and try this one as well. It's good to see some of you guys are finishing up. That's why we like these types of problems, right? I think it's even less than half the work. Let's go ahead and check, right? We'll need to subtract 8 from both sides of the inequality. And then we'll divide both sides by -5, which will flip the inequality. So I got the absolute value of 6x plus 3 is less than -1/5. Well, now I have an absolute value that's less than a negative. And since this absolute value is always going to be spitting out a positive, this could never happen. So it's simply, well, on the homework it'd be D and E.